The equation of a traveling sound wave is given by y is equal to 6 sine 600t minus 1.8x, where y is measured in 10 to the power minus 5 meters, t in second and x in meter. In the first part, I have to calculate the ratio of the displacement amplitude of the particle to the wavelength of the wave, right? So in first part, what I have to calculate is the amplitude, displacement amplitude, that will be r, and its ratio to that of the wavelength. So this is what I have to calculate. So first of all, let's calculate the wavelength, that is lambda, and it can be easily calculated because we know that the coefficient of x in the equation is equals to k, and the k is equals to 2 pi by lambda, that will be equal to 1.8. Fine. So lambda comes out to be 2 pi by 1.8. Fine. And the displacement amplitude, that is the value of r, is given by 6 into 10 to the power minus 5, because it is given that y is measured in 10 to the power minus 5 meter. So clearly that the dimension of y will be same to that of 6. So displacement amplitude is equal to 6 into 10 to the power minus 5 meters. So just substitute the values now. The value of r by lambda will be 6 into 10 to the power minus 5 divided by the value of lambda, that is 2 pi, divided by 1.8. So to solve this equation, you get the value of r by lambda as 1.7 into 10 to the power minus 5. That is the answer for the first part. In the second part, it is asked the ratio of the velocity amplitude of the particle to that of wave speed, right? That is the velocity amplitude to that of wave speed. Let the wave speed be capital V. This is what we have to calculate. So wave speed is given by coefficient of t to that of coefficient of x. So the coefficient of t is 600 and coefficient of x is 1.8. So this is my wave speed, and v, that is the velocity amplitude, can be easily calculated because I know the equation. Y is equals to 6 sine of 600t minus 1.8x. So just differentiate it once, that is dy by dt. It will give me the velocity. It comes out to be 6 into 1.8 cos of 600 minus 1.8 x. It will be t. So the velocity amplitude comes out to be 6 into 1.8 into 10 to the power minus 5 meter per second. Fine. So substitute these two values, that is v by capital V, comes out to be 6 into 1.8 into 10 to the power minus 5 divided by wave speed, that is 600 into 1.8. So just solve this equation, you get the value of v by capital V, that is the ratio of the velocity amplitude to that of wave speed, as 1.1 into 10 to the power minus 4. That is the answer.